Delaware Tech, Chemistry 110, Stoichiometry with Solutions. Now, we've already talked about stoichiometry using gram mass values for reactants and products, and we've also talked about using stoichiometry with gases, where we're looking at the volume of a gas that might be a reactant or a product. But now we're going to extend this to one more level. We're going to consider solutions of reagents that are either reactants or products in a chemical reaction. So let's look at an example of a typical chemical reaction where we might be interested in looking at stoichiometry that involves solutions. The reaction says how many liters of 0.50 molar hydrochloric acid are needed to react with 6.0 grams of zinc. Well, how do we approach these problems? Well, first we have to figure out what the reaction is we're even dealing with, so we need to write those symbols down. We've got hydrochloric acid and zinc, so we know hydrochloric acid is aqueous HCl. I didn't write the aqueous part here, but you know it's aqueous since it's an acid. The zinc is zinc metal. Complete the reaction. Well, this is a classic single replacement reaction, so we know the zinc and the hydrogen will replace one another, and that will result in the production of zinc chloride. And use your crisscross simplify rule to figure out the formula for zinc chloride. Zinc forms a +2 ion. Chloride is already a -1 ion, so it's ZnCl2. And hydrogen that's released, hydrogen we know is a diatomic molecule, so it's H2 gas. And here's our reaction, but it's not balanced, so the next thing we have to do is get the balance of this equation correct, and that just simply requires us to double the amount of hydrochloric acid to match. And now all the atoms on the left are equal to all the atoms on the right. We have a balanced equation. Now we know the equation. Let's look at the problem. We need to map out a strategy. We are being asked for liters of HCl solution. We're given the concentration, and we are given the amount of zinc in grams that we start with. So zinc is what we have in this reaction. We have zinc, so we're going to start with grams of zinc. We know that the only thing we're able to convert grams to typically is moles. So we're going to get moles of zinc. And then once we have moles of any one of these four components, we can get moles of any one of the other four components. So once we have moles of zinc, we can calculate moles of HCl using the balanced equation coefficients. And then finally, we'll use moles of HCl to get liters of solution since we know the concentration. So we're going to use the molar mass of zinc, and we can just look that up. Normally, we would have to calculate a molar mass of a reactant or a product, but since this is a single atom, we can just look it up on the periodic table. And for the balanced equation, we're going to use the coefficients 1 to 2 to 1 to 1 for the four reactants and products in this reaction. Zinc has 1 mole and HCl has 2, so we know we get 2 moles of HCl for every 1 mole of zinc. And then in order to convert moles of HCl to liters of HCl, we need to know something that has both the moles and the liters in the formula, and concentration is by definition a moles per liter unit, at least if we're using molar concentration. So we know that 0.50 molar is the same thing as saying 0.50 moles of HCl divided by 1 liter of HCl. And that's a conversion factor as well. And we can either use it right side up or upside down, just like we can do with the molar mass. So now we have all the conversion factors we need for the problem. We look up the molar mass of zinc, which just happens to be 63.58 grams per mole, or 63.58 grams of zinc per 1 mole of zinc, and we can use that right side up or upside down as always. And then our balanced equation coefficients, we already know all of the possible combinations from the formula. And now we can use stoichiometry to solve it. So let's look at the problem again. So here's the same problem. How many liters of 0.50 molar HCl solution are needed to react with 6.0 grams of zinc. We have the equation already worked out. Here's your pathway. And you can break this pathway down into 3 steps. There are 3 arrows. You're going to be doing 3 calculations. We can do these individually like we'll do here, or we can put them all together. But let's first look at them individually. You've already done this multiple times doing other stoichiometry problems. So let's look at the first one. How many moles of zinc do I have? Well, you have grams of zinc, so you need the molar mass of zinc. That's the 63.58 grams per mole. I'm sorry, it's 65.38 grams per mole. And we plug that in, and we see that 6.0 grams is converted to 0.09177 moles of zinc. If we were asked for this as a final answer, we would round it to 2 sig figs, 0.092 moles of zinc. But we're going to be using this for other equations. So let's use the unrounded version to do the conversion of moles of zinc to moles of HCl. We know we have 2 moles of HCl per 1 mole of zinc from our balanced equation, and then that will give us twice as many moles of HCl, 0.1835 moles of HCl. If we were asked how many moles of HCl do we need, we would just round that to 0.18 moles, but we're going to use this to continue to calculate the final volume of HCl. So we need the unrounded volume, and now we're going to use the concentration of HCl. It's in molar, but molar is the exact same thing as moles per liter, or 0.50 moles of HCl per 1 liter of HCl solution. And that's our conversion factor. We're going to write it upside down because we want the moles on the bottom and we want the liters on the top. And when we multiply it out, we end up getting a final answer of 0.3671 liters of HCl solution. And now we can finally round to our final answer of 0.37 liters of HCl. Now, you can do this one step at a time, and there's nothing wrong with doing it one step at a time. But the fact is, these are all 3 simple conversion factors, and there's no reason you can't just write them all together in one formula. And just remember that the red conversion factor is turning your grams into moles, because grams are on the bottom, moles are on the top. Whatever's on the top is what you're turning it into. So we're turning, with the red conversion factor, we're turning grams of zinc into moles of zinc. With the balanced equation coefficients, we're turning moles of zinc into moles of HCl. And then with the purple conversion factor, we're turning moles of HCl into liters of HCl solution, which is what we want in the end, and we get the exact same answer if we do it all together in one shot. So that's one example of using stoichiometry that involves solutions of a reactant or a product. You can do this with reactants or products. This happens to be an example with a reactant. So let's look at the exact same chemical reaction, but ask a totally different question. How many grams of zinc will react with 0.375 liters of 0.50 molar, remember that's moles per liter, HCl solution? So this is just the opposite direction. We're starting with liters of a known concentration of HCl, so we can immediately get the moles by multiplying those 2 numbers together. The moles of HCl, remember volume times concentration is moles, but we can use it as conversion factors, and I'll show you how to do that. And then once you have moles of HCl, you can turn that into moles of zinc, and then once you have moles of zinc, you can turn that into grams of zinc. And here's the pathway. Liters of solution converts to moles of solution, and you're going to use the concentration as your first arrow conversion factor. Your second conversion factor, represented by the second arrow, is the balanced equation coefficients, and then you're going to use the molar mass of zinc to go from moles to grams. And I put them all together here, and you'll notice these are the exact same 3 conversion factors we used in the previous problem. It's just that all 3 of them are flipped upside down because we're going in the opposite direction. So we're starting with liters of solution. That means we need a conversion factor that has liters of solution in the denominator, in the bottom, where it's going to be canceled. And we're creating moles of HCl on the top. That's the purple conversion factor. Then we turn moles of HCl into moles of zinc using the balanced equation, coefficients. And then once we have moles of zinc, we just multiply it by the molar mass to get grams of zinc. And we end up calculating 6.10 grams, 6.1 grams of zinc. And that's pretty straightforward. It's exactly the same problem in reverse. Here's a different version of this problem. If 96.6 milliliters of hydrochloric acid solution reacted with 2.47 grams of zinc, so now you're given a volume of the acid and the exact amount of zinc, what was the molar concentration of the HCl? So this is a little different here. So we always start with the thing we have, but you might say, well, I have the amounts of two things. I have the amounts of the hydrochloric acid and I have the amounts of the zinc. Well, actually, you really only have the amount of one thing here. You have the amount of grams of zinc. You know exactly how much zinc you put in the solution, or in the reaction, excuse me. Zinc doesn't go in solution. It reacts with the hydrochloric acid. And you have a volume of hydrochloric acid, but you don't know the concentration. So you really don't know how much HCl you have to start with. So the only thing you really know to start with in this problem is the mass of zinc. You have 2.47 grams of zinc, and you start from there. And the idea is to eventually get the molar concentration of zinc. Well, we know we can turn grams of zinc into moles of zinc. We know we can turn moles of zinc into moles of HCl. And then once we have moles of HCl, how do we turn that into a molar concentration of HCl? Well, the definition of molar concentration is moles of HCl divided by liters of HCl. Well, we can calculate the moles of HCl using this pathway. It's the third value in this map of the strategy map. And then we're going to divide it by the volume, but the volume has to be in liters. And you'll notice in the problem it says 96.6 milliliters, so we'll first have to convert that to liters. So let's first determine how many moles of HCl we have. We use normal stoichiometry to do that. We start with our 2.47 grams of zinc. We divide it by the molar mass to get the moles of zinc. So if we stopped at the red calculation, we would have the moles of zinc, but we don't want moles of zinc, we want moles of HCl. So we use the balanced equation coefficients to go from moles of HCl to, moles of zinc to moles of HCl. And we get a calculation that we have 0.07556 moles of HCl. I'm not rounding the number because I'm not done with the calculations. Now, you'll notice we stopped after two steps, and we could have put them all together, but I want to show you the last steps separately. Now, first, we have to figure out our volume. We already have the number of moles of HCl, so that's more than halfway to get to molar concentration. And now we have to convert our milliliters of solution into liters of solution. So we're just going to divide it by 1,000 because it's 1,000 milliliters per 1 liter. Remember, you should always have less liters than you have of milliliters of something because a liter is a much bigger unit, so you want a smaller number, and that's your check to make sure you divided or multiplied the right way. So we end up with a volume of 0.0966 liters. Again, I didn't need to round in this case, so we have our number of moles, we have our number of liters. The concentration is just moles divided by liters. And we end up calculating 0.78218 moles of HCl per liters of HCl solution, or moles per liter. And that's the same unit. Moles per liter is molar. Remember, that's molar. It's not just moles when you see the big M. It's moles per liter. And of course, we have to round this, and we look at our back at our original problem. We have two number values that have 3 significant digits, and all our conversion factors have more than that. Our first one in red has 4 significant digits. Our second one in green actually has infinite significant digits because it's an exact ratio of moles to moles. And our third conversion factor in purple is 1 liter to 1,000 milliliters. That's an exact conversion. So that also has infinite significant figures. So of all those 5 numbers we're looking at, three significant digits is the least, so we round it to three significant digits, or 0.782 molar, that's moles per liter, HCl, and that's our answer, and we'll stop here.